This week we're covering alternative consensus and enterprise blockchain, and we have two guest lecturers this time. First we have Mahir and Tobias, who's going to be giving the enterprise blockchain. I'm sure they'll introduce themselves ahead of their sections. So yeah, let's get started.
Cool. Hi, I'm Mahir. I'm the VP of Operations for the Bitcoin Association in Berkeley. And I'll be speaking on the alternative consensus side of today's lecture, and Tobias will be joining me for the enterprise blockchain portion of the lecture. Anyway, to get started, so we've seen consensus in terms of proof of work thus far, in terms of blockchain technology as a whole. But there are other ways to reach consensus, and there are other ways to have some sort of authoritative agreement on block creation and blockchain technology. So proof of work, as we understand, certainly has its downsides, hence the need for alternatives, or what we call alternative consensus. So with the proof of work mechanism, there is a massive consumption of electricity with such a high network hash rate and so much computing done just to mine a Bitcoin. There had to be better alternatives. Recently in March, it was announced that the electricity consumption used for Bitcoin and blockchain technology can surpass the entire country of Denmark's by 2020. So there hinted a reason that there must be a better way to create an authoritative decision whether or not to create a block, and just general blockchain security as a whole. So with that, and also another benchmark, understanding how much energy is really being consumed here. In 2012, looking at the history of Bitcoin that we covered in the first lecture, so as early as 2012, the most productive supercomputer was being outconsumed, at least by the entire network hash rate of Bitcoin mining. So with that, going into the first method of alternative consensus, proof of stake. So proof of stake emphasizes individuals' ownerships in the entire Bitcoin network. With that, the higher the stake, higher the collateral, meaning like the more amount of votes you have. So it seems to be like a majority vote based on just figure numbers, based on just numbers or stake in the currency. So for example, Peercoin is a alternate coin that uses proof of stake methods. So with that, what it ultimately does is a majority vote certainly needs to be reached, approximately around 80%. And with that, votes are considered, and the more you own in the blockchain, or the more you own in the Bitcoin network, the more your vote counts. And with that, there's certain questions about the financial incentives, meaning that if you have more invested in a Bitcoin network, does that mean you have a higher chance of reaping the rewards? Yes, to a certain degree. Certainly, we're going to talk about how exactly they make the playing level a little bit clearer. And the next form of alternative consensus is proof of activity. So it's this great hybrid between proof of stake and proof of work, where they use proof of work mechanisms to create the foundations required to build a block, but then they use proof of stake methods in order to verify its building, its construction. And with that, it really only exists in theory. Its implementation has been little to none thus far. Certainly, there's room for it, especially because of its hybrid capabilities, and of course, what exactly that means for the development of blockchain technology as a whole. And moving to the last alternative consensus method, proof of burn is an interesting sort of lottery system, in which for your activity in the Bitcoin network, you receive some sort of coin that gets thrown into sort of a pool or like a lottery, in which the more ownership that you have in the network, the more coins that you have in this lottery system, and I guess a certain number of individuals get to split the blockchain rewards, the mining rewards, and with that, again, the higher amount of membership that you have in the network, the more likely you are to be picked for proof of burn. And also Sunny is working on another form of alternative consensus.
Called proof of block. We're basically using like trusted execution environments to like prevent the use of like ASICs in like using proof of work. Because proof of work, because of the rise of ASICs, it's become really centralized the mining, and the other reason is also because it has much faster verification times. And essentially, how it basically works is that like we use like random sleep times that have to be executed in a trusted execution environment. And the thing is, like, every laptop nowadays has a trusted execution environment, so it's much more egalitarian, and everyone has like an equal chance of like becoming the block winner.
Yeah, cool. So the other alternative consensus forms. There's also like proof of activity, but its main replacement for proof of work just tends to be proof of stake. So with that, like Purecoin uses proof of stake as mentioned, and with that, certainly more methods have come in white papers and have come in the research field of Bitcoin as a whole. But certainly, there's going to be far more integration moving forward. So reviewing and recapping over the Byzantine generals problem, we certainly talked about it in previous lectures. And with the Byzantine generals problem, we're now going to be connecting it into like why it's so important for a consensus, and where alternative consensus platforms really benefit the Byzantine problem. So to give some sort of background and some sort of review, there are a number of generals circled around a city, and they have to make one general decision. They either have to attack the city or retreat. There's a physical separation between all the generals, and what that happens is messengers have to convey information between each general. And for the purpose of the metaphor, so generals are computers and messengers are the digital communication systems. So with that, so messages have to be physically passed off, and at no point do they all convene together. And with that, if we take the example of, let's say, 9 generals, and there are four generals that are voting for retreat, and there are 4 generals that are voting for attack. This 9th general, or this like odd general, can actually maliciously split the vote in terms of telling the 4 generals that want to attack that all generals are going to be attacking, and the 4 generals that are going to be retreating, the one malicious general could tell them that they're going to be retreating. So with that, 2 separate messages can be sent, and also with the purpose of like relating this to sort of digital communication systems in general, null or just no response from any sort of general has going to be some like predefined value. Generally, for the purpose of the problem, it's going to be a retreat. So giving the background of the Byzantine generals problem, there are certain mechanics, so there's certain like figures that really need to be stated here. So majority is based on 2/3 vote, and if greater than 2/3 vote cannot be achieved, then nothing really happens. But if there's 1/3 or more of generals that act maliciously, then this entire network can be entirely messed up. So looking at that in terms of the metaphor of like the hash cache problem and where this gets into Bitcoin, we're going to be looking at like fault tolerant systems, and most of like the failure modes of these entire systems kind of falls on the fail stop mechanism, meaning that when there's one destructive node, then all nodes continue to work or like cease to work, and just reduces functionality. Meaning that it's very recognizable that when a malicious node or when one node becomes corrupted, all other nodes act differently. Meaning there are some telltale signs. But with the Byzantine generals problem and relating it to the 9 generals, if this one malicious general causes 4 of the generals to attack and 4 of the generals to retreat, then 4 generals are going to go die because they got the wrong message and they attacked the city, and then 4 generals. I don't know, maybe might feel guilty that they didn't all have their plans together. So the point is that when there's physical separation and when messages can certainly, its origin can certainly be in question, meaning that if that same ninth general claimed to have gotten it from his lieutenant above him, then we don't know who exactly is the malicious one. And also, if two separate generals both get, if one general communicates with another general and both of them differ, one of them wants to retreat, one of them wants to attack, and certainly notices that one of them has, they have conflicting final orders, then creates a problem right there, where between those two generals, let's say both of them act truthfully, then with conflicting final messages, then there's a problem where the two of them stop trusting each other, and the two of them can like start suspecting each other of malicious intent. So it's important in the creation of Bitcoin technology as well as just the general creation of alternate coins. So Satoshi's final paper, Satoshi's white paper describing like the mechanisms behind Bitcoin in the final section. It talks about the direction of truth as the network grows. So as more generals are created or as more computers are created, if malicious generals or malicious computers start invading the network originally, then it's going to be far harder to stop this sort of malicious direction of where the network is going, the general corruption behind it. So really, there's actually like some pretty intriguing math behind the final section of Satoshi and like what exactly it means when, given the proportion of malicious computers and given the proportion of truthful computers, where exactly the network as a whole will go, and like possibly what percentage of it becomes corrupted, at like what point does it get destroyed, at what point does it get found out. So yeah, it relates back to this how difficult of a failure mode it is in fault-tolerant computer systems. And yeah, it applies to Hashcash using Bitcoin. So with that, and sort of connecting to real-world examples of alternative consensus, Ripple is founded between financial institutions and sort of market makers, meaning Morgan Stanley, Bank of Canada, and like many other top 25 banks across the world are using Ripple as a quicker mechanism to move assets around. So getting a little bit into the like economics behind Ripple. So we're often trading with fiat currency, as well as like we can also be using Ripple currency as defined, called XRP. So Ripple may not apply to our everyday lives. What it allows Morgan Stanley to do is like certainly have access to asset vehicles and be able to transact them in a much quicker mechanism than like trading them through some sort of commercial bank like Wells Fargo. So it's a much quicker technical system for them to be moving like loads of money around. And so with Ripple, there's a centralized ledger that just keeps track of debt obligations. So debt obligations is the part of like a balance sheet or just pretty much what people owe. With that, Ripple is not in charge of like keeping track of like how much money is in your account. What they're actually keeping track of is whether payments have been made, meaning that whether debts are owed between two parties and whether or not they get cleared up. So and with that, so Ripple is this sort of like centralized, is the center of this market point in making transactions between market makers like hedge funds, like BlackRock, for example, general asset vehicle companies. So once Ripple was created, approximately in 2011, 2012, one of its co-founders found some sort of flaw with Ripple and decided to create Stellar. So Stellar is considered to have far better technology. Coincidentally enough, after that same founder that left Ripple left, like 2 or 3 months later, there was some sort of attack on Ripple, and its validity is certainly in question. But anyway, so Stellar is used more for peer-to-peer use than Ripple is. With that, there's again, it still utilizes the idea of a ledger, and with a network of computers just creating some global value network and stuff like that. If you read the readings from assigned last lecture, there's a cool little comic on the stellar.org website, And with that, it describes quorum slices. So quorum slices is this intriguing concept where between a network of people, between myself and another person in the room who I have no idea, who I need to make a payment to, but I actually have like no trust in, I can use sets of networks or sets of overlaps between the two of us, meaning that if I don't know someone, then I can use quorum slices to find overlapping networks between them, meaning that I can hand off my money to someone who knows someone, and that same person hands it off to someone who knows someone, and that final someone hands it off to the person that I originally had the intent of moving that information or that money to. So that's the use of like the ripple effect, meaning that if I start at one point, I sort of like go down this list of trustworthy quorum slices to eventually end up at my individual. So with that, it's a pretty quick. The ledger is actually pretty quickly updated every 2 to 4 seconds. And approximately an 80% consensus needs to be made, meaning that 80% of the people involved in like the quorum slices or like the transaction between myself and another person just need to like verify the trust that's handed off to the next person in line for them. Yeah.
And does it use its own currency?
Yeah. Stellar allows for fiat currency, meaning like USD, for example, but it can also use its own currency, similar to what XRP is for Ripple. So an interesting point when Stellar was first created, it needs to be backed by some sort of valid currency and not the Stellar currency itself, because the valuation of that currency at the very beginning is not even defined. So it was originally transacted in USD, and once they had enough people trusting the Stellar network and enough people on the network, it moved to its own currency, like sort of its own central bank, and it ultimately created a pretty reliable currency as a whole. Yeah. With that, I'll be passing it off to Tobias for the enterprise part.
So as you said, my name is Tobias. I'm from the Netherlands. I'm majoring in IEOR, so Industrial Engineering and Operations Research. I'm here for Exchange program. I'm helping the Bitcoin Association setting up the blockchain association. And so I don't code, but I know the business side and I know the system side and process side, and that's also, I think, where the enterprise blockchain comes in. So I want to give you an update on what we see as an enterprise blockchain. Of course, enterprise says like big companies, big organizations. So yeah. So basically, there are 3 waves of blockchain developments. The first one was with all the bitcoins and altcoins, and we saw that they were on the blockchain. Of course, the technology behind the Bitcoin is of course the blockchain. So in the second wave that we got was that we now understand that the technology is also can be used for different type of things. So smart contracts, smart properties. I'm gonna dig into that a little bit later. Also known as programmable money, and DApps, DAOs, DEX, and DESs. But again, we're gonna dig into it later. So smart contracts. What is a smart contract? A smart contract is more or less like a paper contract that's being translated into a piece of code. Or we can also say we're expressing business language into a computer program, which can possibly negotiate or can self-execute on the blockchain. So what we do, we have a contract, we create the code, we put it on the block, and within the block it gets a timestamp and a signature, and then you have a secured contract on the blockchain. So using this digital signature to prove to send the message, and putting it all above, of course, on the blockchain. So let's dig into a little example. So we have a blockchain with Alice, Bob, Tobias, and Max. And Alice and Bob are going to have a contract with each other. Bob wants to buy a product from Alice, and Alice wants to send the product to Bob, of course. So they agree upon a contract with the both of them. So they made a smart contract, put a little piece of code in it. You probably know better the code than me. And within that code, there's a rule between Bob and Alice that when Bob sends the money to Alice, that Alice directly sends the product to Bob. So this is a very simple supply chain, but you can make it even better if you want to with stock trading or something, that you have a negotiating rule in the code, so that if you say I want to cap off at this price, so the contract will eventually negotiate on itself instead of humans negotiating on prices. So the really interesting thing about the blockchain smart contracts is that everybody has a copy of the contract. So when you create a contract between Bob and Alice, everybody will get a copy on the blockchain. So on every single node there will be a contract that's saved. So if Max wants to make a change in the contract, everybody gets a message that Max wants to make a change. Because he's not involved in the whole transaction, so why should he change something? So he will send a message to Bob and Alice, and of course to Tobias, in order to know if he can change something. But we don't think it's a secure message. So then we break the contract, and the contract is lost. So but what if we have a good contract? So Bob and Alice, they have agreed upon contract. Everybody has the copy. So Bob will send his money to Alice. The contract or the code will see that the money comes in. It can be done by Bitcoin, it can be done by Ethereum, because Ethereum is very famous, of course, for their smart contract side. So Alice will recognize that he sent the money, and automatically another system will be executed in order for Bob to receive his product. So this is a very simple explanation, but maybe somebody has questions about the smart contract side. Is it clear for everybody? Yes? So what are the pros and cons? The pros is that it's self-executing. So it can self-execute on the rules that you set in the contract. So that's very handy when you have a contract that you don't want to be humans to be involved in a contract. It's secure because everybody has a copy, so not everybody can make a change in the contract. And what's a very interesting thing is that you could have a machine-to-machine contract, so that machines communicate with each other about possibly commodities that they need, and that they buy it on a certain time, so they can have a contract on their own behalf, and then buy some commodities if they think that's on the right price. So imagine two production machines who have their own contracts. And the cons are the scalability of the chain, because the bigger it gets, the more difficult it gets to compute the whole blockchain with all the smart contracts on them. And it's also difficult to update a smart contract, because we know we can put one on the blockchain and then let it execute, but it's difficult to maybe make changes. Or you can either make a new one, but if you want to make changes to the blockchain, a couple of nodes need to agree on that this change is okay. So DApps. First dig in decentralized applications. Decentralized applications is simply just an application that runs on a decentralized network. And a decentralized autonomous organization and corporation is an organization or corporation that completely runs on an autonomous organization. We're going to dig into an example later on. So it completely runs on a decentralized network. And decentralized autonomous societies is like a bunch of decentralized autonomous organizations and corporations, and there are multiple blockchains, and together they see them as a society. So, for example, you see a large bank who has a blockchain. You have an insurance company who has a blockchain, and maybe something else like a car rental, or I don't know. And they're all together in one chain, so they call it a decentralized autonomous organization, because they can communicate with each other and exchange things on the blockchain with each other. So, for example, Dash. Dash was formerly known as Darkcoin, but they rebranded in 2015 because Darkcoin is not like the name you should have as a coin, of course, because it's related to all the bad things that happened with with cryptocurrencies. So it's called Dash. They communicate via a network protocol, and what makes Dash like a DAO? They have a different type of rewarding system. Bitcoin, if you mine a Bitcoin, everybody gets the 100% reward for mining one Bitcoin. And with Dash, the miners get 45% for generating the block. The masternodes will receive 45% for hosting the masternodes, and 10% will go to the necessary investments. And what makes it a DAO instead of like a normal organization is that with the masternodes, they need to vote on where this money is going to be spent. So, for example, Dash wants to expand or wants to invest in something like a second network, or they want to invest in something on the website or marketing, I don't know. All the masternodes need to agree on if they want to, that the money goes to that place. And for example, if you have a normal organization with a CEO, so a centralized CEO, he makes the decisions where the investments go to. And now you can see like a decentralized organization, everybody needs to agree on where the money goes. So, the third wave of blockchain is going to be for digital ID verification, ID protection, IP protection, intellectual property, and media management. And those are all very interesting because then that's where all the large newspapers, photographers, and also the pornography industry. Naughty America just announced that they're going to use the blockchain in order to secure their whole database, and it's very interesting for them because now they can just say that something is from them instead of that somebody downloads it from, of course. And different types of things are videos on YouTube, so you can just download them anymore, and maybe YouTube can use sorry.
I didn't know that you have. Can you explain what you mean by justice applications?
Justice application. So it's more or less for the government. Justice applications are for like police that they can use to securely. Because if you're a police officer, I write your ticket for you, of course, right? And I put it on the blockchain, I can't change it anymore. But instead of that, I have a paper one, and I sit in the car and I can change something, and I can change your name or anything. Now I can just put it on the blockchain, and then it's secure. And then I know as a civilian who got a ticket that I can trust the officer who wrote the ticket instead of that he does something different with it. That's a very smart example, but you can also think about maybe I don't know. There are a lot of things that you can think about. So mostly what you see in the blockchain 3.0 is that the government and healthcare will come in, and that they're going to use the blockchain for different types of applications. So that's where the large enterprise organizations come in. So what do you think about as applications? What I said, healthcare, so you can do patient registration, fake pharmaceuticals, medical research data. And what's also very interesting for healthcare industry is that they can have a blockchain together with an insurance company. So imagine I have a document, my own medical dossier, and I get it from the hospital, of course, and I want to redeem something from the insurance. I could just show the insurance that I have these kinds of medicines and this kind of therapy, and they will see that it's real and that they are not like try to fuck the hospital or something. You know, it's really clear for them. And for the government, ID registration, so your own California ID. You can also secure it on the blockchain, of course, and tax payments. Finance and investment, we know everything about like the companies as Ripple, JP Morgan, Barclays. They're all investing heavily in the blockchain. So that was also like the first wave where they make use of the smart contracts, and this is now really booming. And the healthcare and government is now really coming up in order to explore the blockchain. But the difficult thing with healthcare is that they're already behind on IT systems. So imagine for them that they need to adapt to a blockchain already in maybe 5 years. So it's going to be a very nice challenge for them. So this is just what I said. This is Epic. Epic is a large software supplier for hospitals. Imagine if they don't make use of the blockchain in a fast amount of time, they will get out of business. And what I just explained with the medical records, I forgot to place in the insurance company, but you can exchange all the documents with the insurance company and the hospital together with of course the doctor who placed the information in your dossier. So just wrap it up for a little bit. We'll just explain what to expect if you will look at the blockchain and the development of blockchain. We're now in 2016 and we're going to 2017. So a lot of businesses are having a proof of concept. So they're trying to do something with blockchain. They're trying to explore the different applications. So in 2017 and 2020, they expect to have a large worldwide shared infrastructure. They're already like Ripple, Hyperledger project, where they create massive global infrastructures. And in 2021 and 2025, they expect that there's going to be a boom like the internet. When the internet, 1995, the boom came. They expect this for the blockchain that it is in 2021, 2025. So this is from JP Morgan. They wrote a report about it. If you want to, you can just Google it. So private versus open blockchains. What's a public blockchain? A public blockchain is just like Bitcoin. Everybody can read the different transactions. Everybody can join the blockchain if they want to, and everybody can participate in the whole consensus process if they want to. Then you have the consortium blockchains. So as companies, where the consensus process is controlled by a pre-selected few. So imagine you have a consortium of 15 banks. Then you have at least you need to have 10 banks that must sign every block in order for the block to be valid. And then you have a fully private blockchain, where the blockchain is, for example, I have a company and I want to make use of blockchain. I'll make it privately, so I can just permission all my managers that they can have writing access to the blockchain in order to change contracts or to apply smart contracts. So it's fully restricted and arbitrary to an arbitrary extent. So what's the difference? We have with the public, you have open writing and open to read and write access to the database. And with a private one, only the permissioned ones can have a permission to do something on the blockchain, on a database. The public one is slower because it's way bigger than if you have just one company on the blockchain. So imagine, of course, the Bitcoin again. It's a very large blockchain, so it takes a lot of time to process everything. And if you have just a small private one, it's faster. With the security that we just talked about, proof of work, proof of stake, and here you only have a pre-approved participants who can take to participate in the whole blockchain. And the funny thing is, with your identity on the public one, so public you think it's public, but it's anonymous, so you anonymously act on the blockchain, and within the private one you know all the identities because you permissioned all the ones in the blockchain, so you know who they are, you know the names, you know the information. And for asset types, native assets, and for any types of assets, for the public one, everything is more expensive because it's way larger, and for the private one, it's cheaper because you have a smaller one. But of course, you can expand, so you can also make it more expensive if you want to. Any questions on the private or open blockchain? Nope. So what kind of limitations do we have? Because it's not all good what they do with blockchains, of course, or the development right now. So we have some technical challenges, the throughput, and also security, because we think it's secure, but there's still being attacks on the whole blockchain. So we need to dig into the more different type of alternative consensus methods, and especially for the private ones, of course. And the business model changes. Imagine if you have a large corporation who's going to adapt to a blockchain. They're going to use a couple of middlemen instead of having like trader houses or exchange houses who take care of the different type of exchanges. Now you don't need anybody anymore. So you need to think about a different business model. And this is hard for some traditional businesses because they were created on this, and now they need to adapt to a whole new business model. Of course, the government regulations, because the government still needs to wrap a head around what's going on with the blockchain, and then the privacy regulations where we still need to wrap around also our heads off. So to dig into what kind of platforms and software you have. So for the private platforms, you have Ripple, where we just talked about with and then we have the private software, digital asset holding, Iris Industries. Please go to the website because it's very, very good to read all the materials on there, because they allow you to create your own blockchain, your own little private blockchain if you want to, and they have a lot of interesting documents on there to learn more about how to do something with blockchain. And then we have Chain.com, who's trying to connect enterprise software to the blockchain, and the Hyperledger project. So, May, a little bit of the Hyperledger project?
Absolutely. So with the Hyperledger project, increases public interface, allowing for distributed ledgers to be used outside of Bitcoin purposes. So with that, one example of where Hyperledger is going with autonomous journalism, anonymous journalism, where journalists can report media files or pieces of information in media suppressed countries. And with that, their identities are not compromised, but it's on some sort of public ledger that's accessible to the general public or people that are guaranteed are granted access. So it's this dispersion of information outside of just blockchain technology, and it relies similar on the same exact mechanisms or the same benefits of general ledgers and the general benefits of blockchain.
Yes, thanks. So with R3, they're building both software and a platform. You can Google Corda. They're creating a large network for 50 of the largest banks in the world. And the Corda project makes a large distributed ledger between all the 50 banks, so you can call it a consortium possibly. And they're very interesting and also private, but a very large private blockchain. I don't know, I want to show you a video, but I don't think I have the amount of volume, but we will try. This is a small introduction to their system where you can see hands-on what's going on with you can see a real running application. So this is the Berkeley's CIO, I think, or he's the Vice President of Innovation. So.
Now we have our legal agreements in place. The next step is to enter a trade. So we'll select an interest rate swap. And then on the left, you can see the trade entry details. This is itself also a smart contract template. We'll enter the one remaining field, and then on the right, you'll see automatically the corresponding legal documentation is pulled up with the trade. And we submit the trade. The next step, the counterparty reviews that trade. And if you're looking on screen, they're waiting for it to arrive. There it arrives, you view this trade, and then affirm it. At this point, we have a smart contract, and we can deploy it to a distributed ledger to run. Now, for our demonstration today, we've chosen to use the R3 Consortium's distributed ledger platform, which was revealed a few weeks ago and is known as Corda. Note, this is the first time that the Corda platform has been demonstrated in public, and Barclays is proud to run an application on it. This is history in the making.
So what you see is that the Barclays is one of the biggest banks in the world. Is doing really something with distributed ledgers and smart contracts. This is amazing to see that they build a whole application to do different types of trades. So now you can see that the world is really changing on besides of doing trades and everything. So this is being launched the upcoming months. I think it's launched because this is the launching moment, but I don't know if they now use it internally. But it's very impressive what they are doing. Oh, how can we switch? So yeah, we have Chain.com, and Chain.com delivers or offers three types of solutions. So we have an open standard where you can just trade your financial assets or do your financial asset registration. Chain Core, we'll dig deeper into that a little bit later. And the Chain Sandbox, it's really interesting for people like you if you go to a financial institute and you want to do something with the blockchain. They allow you to play around and create your own private blockchain on their system. It's like a web-based application, and you can make smart contracts and everything. So you can show your executives if they're possibly interested, or you can show them the interest in the blockchain. So you can build your own applications in that environment. So in the Chain Core, what they have, so you have a whole blockchain network of all different companies. And what they build is a communication layer that communicates with an existing ERP system or CRM system, I don't know, invoicing system. And then they connect it with a blockchain. So on the blockchain you have your asset issuer, so maybe a trader of somebody, and an account manager who is possibly going to say something to him, and then you have the block generator and the block signer. So this is the blockchain part, and this is the distributed storage layer. So it's very interesting what they do, that they try to create an enterprise software for large companies, and they want to communicate with them, because for a lot of large corporations it's very difficult to completely turn around and use a complete blockchain, but instead of they just create a method to communicate with ERP systems and let them use the blockchain through their ERP systems. So this is very interesting what they're doing, and they make the adoption curve for large enterprises much lower in order to use the blockchain. So then we have Ripple. I'll show you a little bit video to close from Ripple, and then yes.
Ripple, the global real-time settlement network. Consumers and businesses have new and increasing demands for cross-border payments. Ripple connects banks around the world and allows them to offer real-time cross-border payment services to their customers. Currently, cross-border transactions require many intermediaries to execute, so settlement takes multiple days. This often creates costs and risks that make it difficult to meet today's market demands. Ripple enables cross-border payments to execute directly between banks within seconds, and provides the banks end-to-end visibility throughout the whole process. Ripple is infrastructure technology banks can adopt to power new payment services like low-value retail and corporate payments. Let's see Ripple in action, enabling a person-to-person remittance use case. On the right-hand side, you see a bank's mobile app. On the left-hand side, you see Ripple powering the core processes to execute a cross-border payment. Alice, a bank customer in the US, logs into her mobile banking app. Her bank uses Ripple for cross-border payments. She wants to send money to Bob, who lives in Singapore. Bob's bank also uses Ripple. When Alice selects Bob as the recipient, Ripple allows her bank and Bob's bank to exchange sender and recipient information to meet risk and compliance requirements. This information is encrypted and exchanged directly between banks via HTTPS. No customer information ever touches the Ripple network. Alice wants to send $1,000 to Bob. Ripple queries the banks for their fees and the network for a real-time FX quote. Ripple packages this information to show Alice the total cost of her payment to Bob in Singapore. Thanks to Ripple, banks can provide customers an accurate total cost, delivery time, and delivery amount for cross-border payments, down to the cent, before the payment executes. After Alice approves the payment, settlement takes place over Ripple in 5 to 10 seconds. Simultaneously, Ripple triggers Alice's bank and Bob's bank to update their ledgers. As soon as the funds are posted into Bob's account, Alice is notified. Ripple solutions afford banks access to transact direct.
So what you see happening here is a large competitor for TransferWise. I use TransferWise to transfer my rent to my roommate, and it takes 3 to 4 days. And with this Ripple, you can just do it in 10 seconds. So it's amazing what they do. I can just transfer. Oh, sorry.
You were saying there was a security vulnerability that was exploited in Ripple. Could you maybe elaborate what was that was security?
The security.
That's a good question. What exactly happened with Ripple?
What was it again?
I don't know, but I can get back to you on that. I'm not exactly sure how exactly what the attack actually entailed, but I can look it up and get back to you at the end of the lecture.
I think this is just based off of what I remember in the news. I think that Ripple was not coming to consensus. Like it kept on forking with itself, like, not purposefully. So yeah.
So what I would say, the world is going to change due to these kinds of technology. So we're setting up a blockchain association, and yeah, if you want to join, and Max is going to tell you something about it also. So.
Oh yeah. So we've mentioned many times how the whole industry is moving away from Bitcoin towards blockchain. To kind of meet that demand and kind of foster this blockchain community in Berkeley, we wanted to start a blockchain division of the Bitcoin Association. If things go well, then it'll probably split off into its own organization. But we really want to see what we can do. There's so much opportunity for clients that want blockchain solutions. Like the CEO wants some hip solution. Oh, we're using blockchain technology. So there's actually a lot of money that you can make doing a blockchain consultancy, where you look into their business, look at where they can benefit from blockchain tech, and then actually build out the applications. So since we're starting this, it's probably going to be a very inward-facing process, like very focused on like self-growth, building up the human expertise, and then we can really start pulling in some deals. Right now, like blockchain developers make over 200K a month. There's also there's a huge demand for blockchain developers. So, yeah. So
this is true. Just say it through.
Yeah. So we're also thinking about starting a workshop series.
Yep.
For like developers, like people who already are developers, but then we'll teach you all about blockchain. We'll teach you how to develop on blockchain technology. Then here's our consultancy where you can actually like make some money too. Like we can get sponsors, connect you to people who will hire you for a lot of money. So yeah, if you're interested, you should reach out to Tobias, who's getting this effort off the ground.
Yeah. And one thing that's very interesting about consultancy is that you will be connected with people like me who have knowledge about system and processes of companies, and you're a programmer, so you can work together with people of backgrounds you never worked together with before. So it's very interesting for the companies to see that we have developers and business people working together on their problems. So yeah.
So you can sign up. There's an interest form right here.
You can also see the link over there. But.
Yeah, here's the link too. Okay, so for next time, we're going to be covering game theory and network attacks. So the previous lecture was mining, and there was a very important topic we left out, and that's mining pools. That's because mining pools have a lot of like interesting incentive mechanisms and a lot of different variations. So we tried to make the readings a little more accessible this time. It'll be chapter 5.4 and 5.5 of the Princeton textbook. And just a few announcements. Bitcoin Association is having another general meeting next Monday at 7 p.m. In 356 Barrows. We're thinking about starting a new project where we help prototype Tumblebit, which is a decentralized trustless Bitcoin mixer. So you get hands-on with some low-level cryptography and Bitcoin scripting if you're interested. And then 2 Mondays from now, we're going to be hosting the lead platform engineer of BitGo at our Berkeley Bitcoin meetup. BitGo is a Bitcoin security company that helps build multi-signature technologies, among other things, and he's going to be talking about securing Ethereum contracts. So yeah, I guess that's it. Thank you all, and see you next week.